I am Sandhya, Assistant Professor, Department of Mathematics and SNS College of Technology. Today we are going to discuss about case study on complex integration. So in this complex integration is a basic fundamental concept of complex number. So what is the complex number? Complex number is the combination of real and imaginary part. For example, 2 plus I3. Here 2 is a real part and 3 is an imaginary part. So the combination of real and the imaginary part is a complex number. So in this complex number we are going to discuss about that is analytic function. So what is analytic function? Analytic function is a differentiable. Not only that z equal to z naught point, it is differentiable the neighborhood point also. Okay. So anyone explain the next concept?
Now I explain about Cauchy theorem. The Cauchy theorem states that if a function f of z is analytic everywhere inside the function, and the integral of the function must be same in the parameter. And there are two important conditions in the Cauchy theorem.
That is Cauchy-Riemann equation satisfied. It is a analytic function is also satisfied. So what is the two condition?
And it should be analytic everywhere inside the region, and it should be not have any holes in the region. If two conditions are satisfied, no matter what we take in the area, then it proves the function is zero.
If it is a mathematically represent, the Cauchy-Riemann equation is ux equal to vy and uy equal to minus of vx. These two conditions are satisfied. It is the analytic function. Okay, next one.
Okay, now I tell the concept of visualization of Cauchy theorem. To visualize the theorem, imagine closed path is such the complex line. When we evaluate the analytic function along the path, total integral becomes zero. Unlike normal calculus, the function analytic is like walking in loop and returning the same point. There is an exchange similarly in physics, like doing work in closed loop with no energy gain loss. This shows that analytic functions are smooth and consistent.
Next we can consider the integral of function f of z is equal to x square plus 3z plus 1. It is the overall closed concept. It is one of the polynomial functions, also known as the analytical function. It is also the complex plan in the polynomial functions no breaks or singularities because the function is satisfied all the theorem of the conditions. We can directly say that the integral is equal to 0. Now let us consider the contrasting case. Suppose next we consider the integral of the function f of z is equal to plus 2 square 3z plus 1. It is the polynomial function. It is a polynomial function is also known as the analytic function. It cannot be break the singularities of other conditions. The functions can apply all the theorem because it cannot be answered contained into the zero. Now let us the contrasting case of the suppose the function is one given by z. This is the function is not given z is equal to 0. Next we consider about the non-analytic function. Non-analytic function is the common to the every sums. You can this theorem cannot be applied at the so the theorem take only the one of the part of the 0 or add on even numbers. This is the region. The key takes out from this case study show the analytic before showing these solutions.
Okay. So is it a singular point? Anyone explain the singular point?
I am going to explain singular points concept. In complex analysis, singular point of function is a point where function is not analytic. That means f of z equal to 1 by z. If z equal to 0, it's not analytic. And next topic is types of singular points. Removable singularity. In removable singularity, the point where function is not defined exists, but the limit exists.
So here the limit is existent. So that is the removable singularity.
So we can redefine the function and it makes it. We can make analytic. Example: f of z equal to sin z by z. If z is equal to 0, the limit exists. Is equal to 1. So removable.
So if it is a limit exists, it is a removable singularity. Okay, means another one.
A point where f of z is equal to infinity.
Infinity. So the answer should be the couple having one by z, it is a essential singularity.
Takes many different values near the point.
So these are the types of the singularity. So
Electrical engineering, it is used in analyzing AC circuits. In few dynamics, it is used for transforming signals. It also leads to an advanced result called the Cauchy formula. Understanding this theorem is a strong foundation for advanced mathematics and engineering concepts.
okay. So Cauchy integral theorem is a basic and the backbone of the signal